So, hi everybody. Officially, I'm Travis. I work at Bowery Farming. We grow pesticide-free produce indoors in New York. We're also hiring for a machine learning engineer and a data scientist focused on agriculture. If any of those interest you, just had to like plug that before I start. And I think you guys all know we're here to talk about selective CI for DBT projects. Although kind of the like second title of this talk could have been DBT and Git diff, a love story. So I guess like the current paradigm that we have for testing DBT models in like CI environments is that you just run DBT seed, run and test in some other schema, let's say. So like CI PR 123 or whatever. The thing that we were finding with this at Bowery though is that it was pretty slow. Sorry, I put in a couple of GIFs into this presentation. And our goal with it is to make CI a little bit faster. So give our turtle a skateboard. Okay, so I guess like the solution that I've like coded up or whatever is over on the right, and then the current CI method is on the left. And so these are this is like our DBT project, and it's basically two separate DAGs. But let's say that when you make a change to model G, outlined in gold here, you would still run DBT seed, run, and test on every single model in the project if you're following the current CI paradigm. So this leads to still running and testing models A, B, C, and D, even though it isn't actually affected at all by the change that you've introduced. So kind of the heart of what this like slim CI tool does is runs only on the models that you've changed. So in this case, instead of just vanilla DBT seed run and test commands, we're running only the model that changed using the @ operator. And actually, I didn't know about the @ operator until a couple weeks ago when Drew told me about it, but it's pretty cool. So the @ operator runs both the parents and children of the node that you select, so like G, but then also runs the parents of the children of that node. So for instance, if model G has the child H, but then F is the parent to H. So it also runs F. Can folks see when I move my mouse, by the way?
Yeah.
Okay, sweet. So we'll run the @ operator on G. So all of the models that are filled in with blue have been run in the CI schema. And then we only run tests on G, the model that changed, and anything downstream of it. Because even though we need model F and model E to be present in the DBT schema in order for all of the models to build, those weren't affected by the change that we introduced in model G. And so the only things that could have possibly changed are model G and anything downstream of it. So model H in this case. And obviously, like, your mileage may vary depending on the kinds of like time speedups that you'll see. And it's really dependent on which models you change, how much time this takes away from the CI builds. But just for reference, before we were running our CI builds on like a subset of data, and it was still taking about 45 minutes. And now with the CI tool, it's about 10 to 15 minutes on average, with like a really wide variance in which models you decide to build. If it's like a giant model, it's still going to take a while. Okay, cool. Any questions before I move on?
Travis, do you have to worry at all about, do you use incremental models anywhere? You have to worry about full refresh versus incremental or any of that?
Yeah, so we will rebuild. This starts from like a schema from scratch, similar to like the current CI environment. So we do fully, like by default, full refresh all of these models since it's in a separate schema.
Got it.
And okay, so you might be thinking, is it really that simple? And the answer is no. There's still a lot of things that could be affected in this like separate schema world. So this yellow thinking emoji face might have a couple more questions for us here. The first of which is, well, what if you change a macro? So in this case, we have our DAG, and model C doesn't actually change, but it uses a macro that changes, macro M. And in this case, by the macro changing, basically anything about that model could have changed. So we basically consider that model C has in fact changed, and then run the same series of commands using the @ operator on C, and then C and the downstream models in test. And it's basically equivalent to if the model C itself would have changed. The next question that the yellow thinking face emoji might be asking us is, what if a seed model changes? And in this case, we handle it exactly like as if a macro would have changed. So if C itself didn't change, but it uses a seed model S that did change, then consider it as changed, run the @ operator on C, and test C and its children. Another thing that can come up in DBT projects is schema relationships. So in this case, you only changed model G, but since H is downstream of model G, that could have changed. And now when we run our DBT test G and its children command, H is going to be looking out for model J because they have a schema relationship here, and it's going to test that relationship. So thus, in the PR schema, we're going to need to build model J as well. So in this case, we'll first run J and any parents, and then just do the testing on models G and models H with G and its children. In a really similar manner, the DBT project could also have data tests. And this is basically equivalent to schema relationships. So let's say instead of a schema relationship between H and J, they're actually in a data test together. So this might be something like you're trying to reconcile two different ways of coming to the same metric. And you want to make sure that those two align, so there's a data test for it. We will build model J and any parents in order for that model to be present in the PR schema. Okay, cool. Any other questions before I keep going?
Yeah, I had a question, potentially silly one. So when a macro changed and we know that model C is changing, what if multiple macros, a macro is being used by multiple models?
Good question. Yeah, in that case, any model that uses that macro would be considered changed.
Right.
And then, yeah, all of these examples are like pretty straightforward and like, oh, you've only changed one thing. But we do handle cases if you've like made many changes, and you need to think about all of them. Okay, cool. So next question, what if you change the schema file itself? So in this case, if you've changed a schema file, you could have theoretically altered any kinds of tests that exist in that schema file. And let's say you like added a new test, and maybe we basically need to make sure that that test passes or would test in production if you were to merge this change. But let's say if you've only changed a schema file, we don't actually need to rebuild the models from that schema file because the data itself hasn't changed. It's only the tests that could have changed. So in this case, we actually don't run any DBT run commands. We only run a DBT test with target production. So in this case, we're only running models A, B, C, and D because they're only the ones from the schema file that changed and in target production. In a similar manner, if you change a data test file, let's say between D and H. We also don't need to rebuild all of those models in the PR schema and waste the time doing that. We can just directly test on production data. Cool. The last question that the yellow thinking face emoji has for us is, what if you change the DBT project YAML? And in that case, I have no idea what to do. Just DBT seed run and test that whole thing, and hopefully it all works out. There might be like something more intelligent to do here, but I did not bother with it. Cool. So I guess in the course of working on this project, I like finished implementing it and then started talking to a few people about like, oh, like what are some other ways that we could approach it? And realized that we still, even with this like slim DBT CI tool, there's other things we could do that are a little bit smarter. For instance, when let's say we have a DAG that looks like this, E, F, G, and H, and we've only changed model G. In the current tool, we basically rebuild any parents in this model, like E and F, but those won't actually change from the current production model. The data will end up being the same. So what we really should do is either copy in the tables from E and F from prod into this DBT schema, kind of inspired by the like zero copy clone thing that Snowflake users can take advantage of, that we'll probably talk about later. Or just if there's some functionality in DBT to directly select models from other schema, we could not even copy these tables in from prod into the PR branch, but just directly select from those models in prod. And then in that case, it would simplify, instead of using the operator, just run model G and all downstream dependencies, and then test G and its downstream dependencies. So I'm like looking into this now. Maybe I'll do this if I have some like spare time. Okay, cool. I have a slide with pseudocode, but I think that's actually not worth going through right now. And I'd rather just jump to a demo. But first, maybe are there any questions before I jump to a demo?
No question. I just want your code to implement it.
Cool. Okay. Okay. So, how is this for size? Is this? Can everybody see the screen? Can anyone not see?
It's good.
Okay.
Can you actually go up one more?
Yeah.
Much better, thank you.
Okay. So on the left here is the folder structure for like a sample DBT project. It's pretty straightforward. There's nothing really fancy in the like DBT project YAML. We just have, you know, models, macros, data tests, and some seed models as well. And it just has some like kind of dummy data in it, or like dummy SQL of like DM customers, selects from SCD customers, and there's some like relationships between all of these. And we are currently on a demo master branch, just to like show what's going on here. And let's say we want to make a change to DM customers. So we check out another branch, demo model change, super inspired name. And then we like go make some change, let's say let's change STD customers actually. Like where Enron and where NFs. Cool. Okay, we don't want those guys as customers. So we're going to remove them in a where clause. Save that file and then commit it. And then we can just run. So I basically have a like make command set up for this. So make test local. And what this does is runs a Python script that has all of the logic in here. So it like activates an environment. We use Chamber in order to like store credentials. and then it runs the selective CI service. Cool. And this no execute flag basically just says, don't actually execute the DBT commands, but rather just print the output of what like the plan would be if we were to run them. In order to run the selective CI service, we do execute DBT list, which allows you to like select different models. And so in order to run DBT list, we need to run DBT deps. So it's like what it's doing up here. And then it gives you an output of what it's going to run and the reasons why, like this little blurb here. So we're basically running every model in DBT seed just to make it simpler. So every like PR schema gets seeded models. And then it's saying that it's going to run, we changed SCD customers, and it's going to run DM customers and any upstream models, because this model is referenced in a data test, test DM and SCD customers, along with model SCD customers with which changed. So we could actually open up test DM and SCD customers in our data tests and see that, yes, in fact, the model that we changed SCD customers is in a data test along with DM customers. So we need to run that model and anything upstream in the DBT run command. Similarly, this little blurb here is saying we're running DM locations because this model is in a relationship with DM customers. So there's not like a ton of models here, and I was trying to like explore every possible avenue of like what could be done. So it's a little like intermarried how many relationships, schema relationships, data tests, and whatnot are between these models. But there's also a schema relationship between DM customers and SCD customers. So for that reason, or sorry, between DM locations and DM customers, which is downstream of SCD customers. So we can check out that schema file and see, in fact, that yes, DM customers has a schema relationship with, or sorry, DM locations does in fact have a schema relationship with DM customers. So that's kind of like the paradigm of like, tell you what is going to run and why, and then run it. And like in the down here, then we have like a final command list. It's going to run DBT run, DM customers and its parents, DM locations and its parents, orders parents, and using the at operator on SCD customers, which actually changed. And then only running DBT test on SCD customers and its children. Okay, cool. Any other questions?
So when you mean a schema relationship, Travis, you mean there is a foreign key relationship between two tables, but because of the way your models are being built, you actually don't have to build one before the other. I'm trying to understand because in all of the models we're working with, there's no such thing as a case where we have a schema relationship between two tables where we don't already have it called out in the DAG.
Oh, interesting. Oh, where it's not being built from one.
Yes.
Oh, I see. Yeah, I guess we do have those cases in our DBT project, which is like kind of why I was thinking about it, of where we're getting like two separate sources of data, but they should match up in a foreign key relationship. And so, yeah.
Gotcha. Okay. One other thing we did do to deal with that is you can we actually have one case where that happens. We put like a dash, we commented it out, but we still put the ref name in the model. So what that means is you don't actually have to use it in the SQL query, but it forces the DAG to think of it as a link.
Oh, interesting. Wait, so you commented it out here? Like,
no, in the actual model. So if you go into the model file and then say at the top, like dash, and then you put a ref statement to the model that you have the schema relationship to.
Oh, interesting. Like in a Jinja block and then.
Yeah. So what it will do is it will it doesn't actually affect the compiled SQL at all, but from a DAG perspective, DBT will consider that as a link, and you'll see it in the DAG. It also makes it very nice from a documentation and a mental understanding perspective, because that way you're not having these hidden things going on that people don't know about.
Oh, cool. Interesting. Nice. Thanks for the tip. Okay, cool. So, I don't know, do you guys want to see like another change, like another example output?
Yes.
Okay.
More magic, yes.
Glad to provide it. Okay, say these. So we just checked out master again, and now I'll go back to my prepared commands so I don't have to think right now. Git check out another branch, and we'll do like a schema change in this case. So we won't change anything in models, we'll just change one of the schema files. Which, okay, it is in the models folder. Well, let's say we like want to get rid of this not null test, for instance. Save it, commit it. Getting rid of test. And then make test local. Okay, cool. So we just changed schemas DM. So let's see here, what happened? Oh, I think another change got looped into this branch somehow. Yeah, sorry, for some reason we're running DM customers. Oh, I think I didn't add it. Ah, sorry. Okay, 1 second. Okay, let's give that one more go. Okay, now we're on a feature branch with no changes staged. That's important. And we'll get rid of that not null test again. Only that one change to commit. Okay, and then now make test local. Cool. So we only changed schemas DM here, and then we're only going to run DM customers and DM locations with target production. So the final command here is run target production, DM customers, and DM locations. And we'll see that, yes, in fact, in schemas DM, only DM customers and DM locations are referenced in this file. Cool.
Do you think this is something that could be built into DBT itself as like a native feature?
I was thinking about it actually, and I was like talking with Drew. I think at this point probably not, because it presupposes that you have Git and you use Git with your DBT project, which sounds like something isn't like not on their roadmap necessarily. I'm like thinking about trying to open source it maybe if there's like interest, slash if I like can.
There's interest.
Okay.
Yeah, for sure. This is amazing.
Okay, sweet. Yeah. Yeah, no promises since it's like not my day job, but I am super excited about this stuff. And yeah, I like really liked this project.
Would it work on Windows?
Yeah, it should, as long as you
Okay.
have Git. Like basically we can go into the code a little bit here too, into the like selective CI like Python package essentially. The only requirements for it are like DBT itself and then like the Git Python client.
Mm-hmm.
I don't think we actually need this like PyYAML package because DBT needs it, but it's in there for good measure.
I just didn't know if there's any like bash dependencies or something in there. That's all I was wondering.
So I haven't actually used it on Windows, but I don't think there would, like, as long as you can use like the in command prompt or whatever it's called, I think you should be able to.
Got it.
Oh, it looks like. Oh, cool. But yeah. But yeah, it looks like Taylor asked if you can use something else besides Git. Yeah, that's kind of like the downside to this. Is anyone?
It's really like what are these people using if they're not using Git? I guess there's still some version people there.
Claire, are there any stats on that?
On Git? Well, you actually, I think Git's required for DBT at the moment. So
Yeah, I was going to say, I feel like this is something that could definitely be first party at some point.
I cannot comment on the product roadmap, though. I'll tell Drew he has an action to follow up.
I mean, either way, this could, if you're cool with it, Travis, make it public. People could try it, and it's a great way to find bugs and get people to make it better collectively.
Yeah, definitely. Yeah, so still, like, we've only been using it for maybe like 3 weeks or something on our team, and yeah, we like found a couple bugs, and I'm sure there's more. But I would love help in finding them.
This is definitely something that I'd be happy to help contribute to, like in that last slide that you showed. You know, I'm sure other people would too. So if you're able to, this would be awesome to get this out in open source and have everybody start hacking away at it.
Sweet, cool. That's good to hear.
Yeah, this is amazing. My question, I know I'm not going to love the answer to this because it's not the right answer. How are you deploying this?
So yeah, we did start using Circle CI for our like CI tool. Yeah, I would love if we could get this into like DBT Cloud as soon as possible, if like it did become open sourced. Yeah. But so as long as you can run Python in whatever CI environment, it should be fine. Like it's pretty agnostic to the CI, like to the which like CI provider you have. It's like Travis or Jenkins or whatever. It should work in any of those.
Or GitLab is the other one that I hear is.
They're all right.
They were just so nice to me at that conference. Yeah, I'm blown away. Like, first of all, by by what you've done. So many edge cases that like I would not have considered. Like amazing work. And also the quality of the presentation and demo that you put together. Thank you so much for that. I don't really have any questions other than like, yeah, I would love to like see the code for it and understand, because like just see more deeply, that'd be awesome. But yeah, I also like had a secondary thing of, I know some other people in the community are doing cooler things than I am with CI. Like my CI builds are as you know, sophisticated as running them as a separate job in DBT Cloud, which like is totally suitable for the 90% of the time. So yeah, I know like Taylor, you've worked on some stuff in your CI build. I think Josh, you've asked some questions about things before, like dry runs and things like that. So yeah, just gonna throw it over. I mean, if anyone has any more questions on this, Travis is obviously sticking around. But yeah, Taylor, do you want to speak a bit about like what you're doing on the CI side of things in your project?
Yeah, sure. I'd be happy to do that. I'm going to go ahead and just share my screen. Okay, does everybody see Firefox and GitLab?
Yep.
Cool. Okay, so I've actually got an MR open here. And so GitLab has the CI kind of built in. And we have, let me just open up the pipeline view actually, so it's a little bit clearer. So we use Snowflake as our primary data warehouse, and on every Git branch, we will make a clone of the analytics warehouse in Snowflake. So there's a job that does that here, and then all of these jobs are scoped to run against that clone, which is nice. And you can also, it'll read from raw and write to the clone of analytics, but you can also have it like read from raw. And then the two big ones are the DBT run stage and the DBT miscellaneous stage. So previously, we basically like would tag a few of our models as product and say like, if you're not running like Snowplow or the GitLab.com data, just do the exclude product and that's going to run what you need. But now that we have there's a relatively new feature where you can actually come in here and specify what model you want to run. And so I've actually got it set up so that I can do, you pass in a variable, so you just do DBT models as a variable, and then you can specify like, I don't know, what's a good one?
SFTC.
What?
SFTC.
Yeah, so I can do SFTC accounts XF, trigger that manual action. And then we've got our own runner set up in Kubernetes. And so it's going to take just a second here to, I don't know why it's, whoop, click the button. Should run here. There we go. So it does a bunch of stuff, but so it'll echo like, okay, what database am I looking at? The analytics clone. Then we run DBT depths, it'll run DBT seed, and then it'll actually run the model and the tests with that scoped variable. And you can actually come into the declaration file for it and see the script here. So I have DBT run, and then it's scoped to the specific, here's the variable. And we have a different one. So if we want to run it on like an extra large warehouse, I've got a separate job for that. And then you can also pass it in as exclude if you want to run everything but a model or two. So that's relatively new. I think GitLab came out with specify variables in like 12.2 or 12.3. So that's the main cool stuff we're doing. Did I miss anything, Emily? And yeah, so I did seed. And yeah, oh, here we go. Yeah, DBT run, it spits out, no, it just got small. It spits out the variable that I passed in, and then that's what it's running against. And it has no checks. If you pass in something that doesn't work, it'll just, DBT will say, I have nothing to do. So job passes. And all this is open. I'll drop a link in the chat to our CI declaration. There you go.
Cool. That's really cool. Thank you so much for sharing that. Yeah, Josh Temple, I should say. I have to specify that. I know that you asked questions about this before. Did you end up doing anything fancy in your CI runs for your BigQuery project?
What was the question?
Did you end up doing anything special in your CI runs? I know that you've I've seen questions from you in the community around this topic, but did you seed test?
No, we're doing pretty much the traditional that Travis outlined of, seed run test in a separate schema. One thing that they'll kind of mention that Dylan and I are working on a tool for Looker users that will be a CI tool for your Looker instance that will be open source. That's what we're speaking on at Join. And so there are some opportunities to integrate that with DBT potentially, where you could look to see, well, if I change a model, does that break my LookML, and make sure that you go and fix that appropriately before you push changes to your DBT project. So there'll be some cool ways to hook those things up down the road.
Cool. Yeah, Taylor, there's a question for you on the chat if you want to read that out and then answer it as well.
Yes, the question is, for specify models, how do you integrate with merge requests? So what I was showing was actually within the scope of a merge request, and the jobs to like clone the warehouse are done in the scope of a merge request specifically. We don't run DBT in production using GitLab CI. We do that via Airflow, and that just runs basically everything. I think we segment a little bit on the warehouse side based on our tags, but that's all running in Airflow. Does that answer your question? Cool.
You're on mute, Claire.
Sorry, I do this all the time. For those of us who aren't on Snowflake, can you just very quickly describe what a zero copy clone is, or explain that part?
Oh, yeah. So Snowflake is a metadata store on the back end. And so instead of doing, when you clone the data warehouse, instead of copying all of the actual data, it just copies the metadata. And so it's still pointing, I think, behind the scenes to a lot of the same data. But it's a much faster way to create a separate environment. It works pretty well. It does scale with your data. And so we have like a couple of terabytes, I think, in our analytics warehouse, and it's taking a little bit longer. So I think we're actually going to experiment with some just like empty clones. We're going to toy around with some different ideas because it's starting to drag the analysts a little bit. And so I want to speed that up where I can. But I feel like zero copy clones is a feature that Snowflake doesn't really hype up that much. They hype up all their data sharing, but I like the cloning feature.
Yeah. How long does, I've never run a zero copy clone. How long does it, like, how long does it take your team? And it's always going to be the environment, but.
The latest one, so I'm testing out storing, like partitioning our snowplow data using DBT. So I'm happy to talk about that later, not in this call. And so copying all of our snowplow data over has started to slow it significantly. Before I did that, it took like 6 minutes. Now it's pushing 20 minutes because it's a lot of metadata.
One thing we do here is we keep a weekly clone, so we do it on the weekends. We make a clone and then we use that for all our testing because that part is not changing that much. Or we haven't had many problems, but I know you can have a race condition where you might have to run it more frequently, but that has helped us keep the speed kind of reasonable, because I think 6 minutes is also pretty long for a pipeline to go and people to get feedback sometimes. So yeah, that's what we do. We keep a static clone going all the time.
And like, just to make sure that I'm clear on this, with the zero copy clone, it's that idea of like, then you can just test the incremental build of things. Like you don't have to rebuild everything from scratch. So what Travis was thinking about doing on Redshift, but you can just do like that.
That's part of it, but it's also like a production replica, exactly, except for the name of the database.
Sure.
It has all the same permissions and all the same data, really. But we're kind of rethinking that a little bit because, especially for CI testing, it's really not necessary, I think, to have everything in there, and it's kind of overkill. But it fits nicely with like Git branches, kind of. So we're still going to test to play around with it a little bit, I think. But yeah, it's just about having a safe environment to play in.
Yeah, really cool. It's so interesting, like dev, QA, production environments in a data, like in an analytics context. Like I worked with a company that, they had all their like dev data as in their Postgres dev database and their events on their like, dev.mywebsite.com, like their segment events, all like streaming through into their warehouse as well. And then when you're doing like production, you're doing transformations on dev data, and then you move like in dev, and then you move it to production and do same transformation on production data. It's too many things changing often. And so yeah, I think there's a lot of no real consistency in like what the best practice is. We usually take the simple version of a new schema is going to get us most of the way there. So yeah, that's what we tend to do. Cool. Okay, another question. Oh my gosh, this question comes up all the time. What are people using for formatting, linting, coverage, etc.? We have a repo that's called like DBT linter, and it says to do everything. No one has solved this, and yeah, I don't know if anyone's planning on solving it. Unfortunately, it's just for some reason much harder than it should be. So we lint by hand. Was there another part to that? Oh, code coverage though. I think, does GitLab have a unit test that every model has to have a test? Or am I imagining that?
It's just a part of our style guide and kind of MR review.
Yeah.
It's like our human linter.
Yeah. Yeah, human linting is not great. But you know.
Clara, on that topic, I know you had put out the Atom formatting package. I don't know if there are plans to update that. Like I know sources is missing from there, some of the newer commands.
Oh, I thought we used sources in there, but
maybe I just need to update then.
Let me have a look at that. I haven't given the Atom package some love for a long time. Taylor's asking for VS Code. That would require me to download code. Taylor, I thought that you weren't allowed to have code on your laptops at your company. Like VS Code, I should say. Yeah, Atom, I'll add it to my backlog to redo. VS Code has a pretty good Ginger package, and so I think it's just about porting over the snippets, which shouldn't be that hard, but it's just because it's not a tool that I use. I haven't had I really built the Atom package for me first. I was like, I'm getting frustrated here. I don't feel the frustration on the VS Code side. It's probably the worst thing a community manager can ever say. I built this thing because I was frustrated. But it was what it was, you know. But yeah, cool. I'll add it to the list. Speaking of my list, someday soon we're going to publish that list so that we can have more visibility on what I'm working on, which is terrifying for me, but yeah, that'll be an interesting experiment. Cool. Any other things to chat through? Everyone that's plus one in VS Code, should I just move to VS Code? Is that the solution? Okay. Oh, we've got our IDE in DBT Cloud coming out soon. So no. Okay. Travis, honestly, thank you again. That was so wonderful. Oh, Josh Andrews, did you quickly unmute yourself then?
Yeah, I was just curious if anybody else had been exploring some of the new Snowflake features, kind of trying to use them with DBT, specifically external tables and/or streams and/or tasks. Just curious if anybody else had been poking at those.
Nope.
No, but I would love for you to, Josh, and do a write-up of it, of what you find. Yeah, I just haven't. I think that's the thing that sort of needs a few hours to just poke around at it, and haven't had it go yet. But I'm really interested in it.
Yeah, we've been poking at external tables a bit and trying to use them as some of our sources. It's kind of cleaner than the way we would do things currently. So literally almost pushing some of our raw sources and really having them being backed directly by S3. You know, but still kind of messing around with it. And we have a pretty clear way to do it through some macros for some of our smaller lookup tables. For some of our large transactional data tables, it is performance. It's still not going to work from a performance perspective right now. And we also have an outstanding bug with Snowflake filed about how partitioned external tables, the partition filtering actually doesn't always work. It does a full table scan even when you tell it to use partitions, sometimes depending on how you specify the partitions. So that's been out there for a few weeks or a month, but I'll keep you updated with what we find. And you know, if anybody else is using that or some tasks or streams or any of that, I'd love to hear about it online or offline.
Cool. Okay.
Before we go, I wanted to say one other thing too, or just kind of like rehash like the current state of like DBT CI options, I guess. So if my understanding is correct, if you use Snowflake, you could use this like zero copy clone, and it's actually super helpful because then you could, if you like combined it with like the tool that I was presenting, just run the models that changed and their downstream dependencies in the CI build where like you have all of the prod data. And so just run and test the models that changed and their downstream dependencies. And you don't have to worry about like schema relationships and all this other stuff. But if you're not on Snowflake, then it doesn't really work. We still have to like get more creative about like copying the correct tables into the like DBT schema, like kind of recreating the like zero copy clone, probably only with the tables that actually matter because copying in Redshift is like slower than Snowflake, I'm sure. Yeah.
Yeah, that's right. zero copy clone is on a whole database, and you can do cross-database queries in Snowflake, whereas you can't in Redshift. So like your schema of raw data and your schema of your production transformations will be like, or your transform data will be copied across into a new database. Yeah, you can sort of play with it from there in terms of whether you want to do a full refresh or just rebuild the incremental, do an incremental build. But yeah, it's, I like looked at that feature when I was using Snowflake and I never got to use it, but yeah, I'm jealous of those that do get to use it.
Same.
There are still some complexities with it. If you're just using tables and views, it's fine. They have a bunch of gotchas about using clones if you're using external tables, task streams, or some other kinds of objects. So materialized views, I can't remember. I think there's still some. So if you're sticking with the simpler objects, it works fine. The more complex stuff, sometimes you have to think about it.
Cool. Good to know.
Other option in Redshift I've seen some people do, but I don't like it as an option, is to take like I think it's called a snapshot of your whole cluster and then like recreate a new cluster. But that's expensive because you have to pay for a cluster, and you can only do that like that in itself is a multi-hour process. But I've seen companies like maintain an entirely separate CI cluster, and yeah, every week they would sort of refresh it from prod. Cool. That's all that I had. I just want to say, yeah, Travis, thank you again so much. That was wonderful. It is not lost on me that we had a conversation about CI with someone called Travis. That was fantastic. I'm so sorry someone had to make the joke eventually. Yeah, just thank you so much for the effort you put in today. And I will see you soon in New York, I'm sure.
Definitely.
Cool.
And,
Bowery hiring. That's the other thing we've got to say.
Yeah.
Okay. Cool.
Take care, everybody.
See ya.
Thank you, Travis.
Bye-bye.
Thanks, everyone.
Thanks.